Hello, second period and eighth period algebra. Big shout outs to Riley and to Christian and to Megan and to Hannah and to Logan and all my other friends, Jillian and Jenna and Kevin. Can't forget Kevin. Can't forget Josh. All right, big shout outs to you guys. Welcome. Obviously, I'm not here. Actually, I am. I'm just hiding in the closet. You can't see me, but I have a little peephole and I can see all of you. So stop yawning. All right, Mr. Laurence here, and we're going to do some practice. All right. Now, what I need to happen is I need a person to pause the video before we actually go to do it. So you see problem number 1 here. It says the absolute value of 3x minus 5 is greater than 7. By the way, don't look for the airliner. You can't use it today. All right. So I need you to have your notebooks out. Solve for x, please. When you're done, unpause the video. Here comes my solution. You should already have done it. So here's what I'm going to do. Since the absolute value is alone, I can rewrite it as two inequalities. So I'm going to write 3x minus 5 is greater than 7, or 3x minus 5 is less than negative 7. Some of you are forgetting to flip the inequality when you make the 7 negative. Don't forget that. How did I know it was an or? Because remember, this symbol here, we are mispronouncing intentionally for a great or. And we know it'll graph something like that, right? By the way, ors are like unions. Did you catch that? Ors are like unions. Yeah, they list the roster of everybody involved, but it's about the union, okay? All right, so I solve both parts. I add 5, and I add 5, and I get 3x is greater than 12. And then I divide by 3, and I get x is greater than 4. Or, and I come over here, and I add 5, and I add 5. You had no idea I was so musical, did you? Good thing I'm not doing my British accent. It would drive you batty. All right, so then we divide by 3 on both sides and we get negative 2/3. X is less than negative 2/3. Let's graph this on a number line. This is really good stuff. Sorry, I'll stop. Okay, so we've got the number line here. Oh no, it's not a number line right now. It's a number array. There we go. All right, so I need a negative 2/3 on here and I need a positive 4. They will be open points, yes, because they're not equal to. And numbers greater than 4 are to the right of 4. And then the numbers less than negative 2/3 are this way. Now, let's give the interval notation. Go ahead and pause it. I know some of you are having trouble with interval notation. Let's go ahead and pause. Stop looking at the next problem, you little sneakers. Let me move this down here. And a boo-boo, you can't see it. All right, so here we go. Interval notation. I'm going to do this part first. I'm going to go all the way from 4, and notice it's an open parenthesis because it's not equal to, and it's going to go toward infinity. Now this part here is coming from negative infinity, and it's going all the way to negative 2/3, but it's not inclusive. Since this is an or, and remember I said before or is like a union, I need the union symbol. There you go. Pretty easy stuff. Let's try another one. Let me get rid of my shade, as long as you promise not to peek. No peeking, duck. Okay, so there we go. And I am going to make one small adjustment to it. I'm going to make it less than or equal to. All right, now, is the absolute value part alone, Hannah? No, it's not. So we're going to use our inverse operation rules, like, listen to Saddam. We're going to get rid of the positive 8. We're going to get rid of the 2. Then we'll be ready to break this up into two inequalities. So I'm going to subtract 8 from both sides. Just like that, a jolly old day when I can subtract by 8. And then I'll get 2 times the absolute value of 4x minus 6. Be less than or equal to 4. And then I will have to divide by 2. Yes, I will. And when I do that, 2's will cancel. And I will get 4x minus 6 is less than or equal to 2. All right, now I can break this up into two inequalities. Hopefully you've paused the video and tried to stop peeking, duck. All right, and so I'm going to get 4x minus 6 is less than or equal to 2, and 4x minus 6 is greater than or equal to negative 2. So I'm going to solve this. I'm going to add 6 to both sides. And when I do that, I'm going to get 4x is less than or equal to 8. I'm going to divide by 4, and x will be less than or equal to 2. All right, here I'm going to add 6, and I'm going to add 6. And I'm going to get 4x is greater than or equal to 4. And I'm going to divide by 4. And I'm going to get x is greater than or equal to 1. Now this is an and I know that ands graph like our thumbs touching, right? So I'm going to have a 1 here and a 2 here. I'm going to have closed points this time because they're equal to. And the numbers that are less than 2 and greater than 1 fall between those like that. If I wanted to go interval notation, where's the set start? Well, it starts at 1, and the 1 is included, so I use the bracket. It goes all the way to 2, and 2 is included, so I use the bracket. I'm just doing interval notation for this part of the picture. All right, now I'm going to try to trick you. Okay, go ahead, pause the video, solve this one. All right, here comes my solution. There is no solution to this problem. How do you know? Well, let's do it the long way. Absolute values alone, so I can break it up into 2 pieces. X plus 5 less than negative 3. And x plus 5 is greater than positive 3. So I'm going to get x is less than negative 8. And x is greater than negative 2. Wait a minute. It's an and, but it's going to look like an or. Did you catch that? It's an and that's going to look like an or. Greater than negative 2 would be that way. Less than negative 8 would be that way. There's no number that makes both parts true at the same time. When an and looks like an or, there's no solution for an absolute value inequality. No solution. All right, I knew that already because it was less than a negative. All right, most kids don't understand what I'm talking about when I say that. But if you can remember, if an and graphs like an or, it's no solution. All right, let's try another one here. Oh, what is this? I don't want the keyboard to pop up. Little gremlin in the system here. Okay, I know the answer to this one already too. I do. Yeah, it's all real numbers. But tell you what, pause it. Go ahead and break it up into 2 inequalities and solve it, okay? All right, so here comes my solution. So we're going to get 2x minus 6 is greater than negative 1, or 2x minus 6 is less than positive 1. All right, so I'm going to add 6 to both sides. We're going to get 2x is greater than 5, and then x is going to be greater than 2.5, I believe, right? Or we're going to add 6 to both sides, and so we'll get 2x is less than 7. Now we're going to divide by 2. X is going to be less than 3.5. Wait a minute. This is going to graph like an and. It's an or, but it's going to look like an and. So if I put 2.5 right here, and then 3.5 right here, I will have open points because they're not equal to. But the numbers that are greater than 2.5 are this way, right? Except they keep going, don't they? Yeah, because these numbers are greater than 2.5. And the numbers that are less than 2.5 are that way. What did I end up shading? I shaded the whole number line. This is all real numbers. Any real number works. Okay, now we're going to change direction a little bit here. And let me see. By the way, I'm going to post this video onto YouTube so you can find it. I'm going to hit publish on, that's the honors one going up. But let's get to you and let's go back here. And I want to bring up, I'm going to bring up some questions from last night's work. Oh, I'm in the wrong place. No wonder, silly me. Okay, first one I want to do is number 9 from last night. So, all right, this is really hard to read, so I'm going to read it to you. Make sure you're listening carefully. You got that, Brenda? All right, so 153 students. 153 students. Okay, it says 98 studied in the library, right? It said 87 studied in the lounge. Okay. 39 studied in both. Okay. And it says of those, oh, I need a similar exercise. Silly me, the answer is sitting right there. Sorry about that. Silly Mr. Lawrence. Oh, dear. Okay, similar exercise. Here we go. Let's try this again. 142 students, 87 in the cafeteria, and 79 in the lounge. 79 in the lounge. 36 studied in both. Of those interviewed, how many students did not study in either the cafeteria or the student lounge? Well, let's make a Venn diagram. Let's do a circle for the cafe. And let's do another circle for the lounge. Now, the first thing I notice is that 36 are in both. So I'm going to put a 36 in the section that encompasses both the cafeteria and the lounge. Now, I know the cafe total needs to be 87. And I know the lounge total needs to be 79. Well, to figure out how many studied only in the cafe, I would do 87 minus 36, and it looks like I'm going to get 51. Not 151, you silly dooger. There we go, 51. All right. To get the number of students that only studied in lounge, I'm going to take 79, and I'm going to subtract 36. When I do that, I'm going to get 43. All right, so there's 43. All right, very good. So, but that doesn't answer the question. The question says 142 students were asked this, so we must have some that were neither in the cafe nor the lounge. We'll put an N for neither. Well, how many students were interviewed? 142. How many were either in the cafe or lounge? The sum of these three numbers. So I'm going to go 51 plus 43 plus 36, and that's going to be a 0, carry the 1, and that's going to be 130. So there are a total of 130 students right here. Well, if there's 142 total students, 142 minus the 130 that studied in either the cafe, the lounge, or both, leaves 12. There must be 12 students. You see how simple that is? It really is easy. You just got to take your time. Oh, look at that. I did a good job. I'm so proud of myself. Okay, let me get rid of all this work. And I also want to look at problem number 10. All right, and again, I want you to pause the video here once I'm done reading it. So, the absolute value of 3x minus 4 is less than 2. And they want the solution is either a union or an intersection. But because it's an and, I know it's going to be an intersection because it's what both things have in common. It's going to be less than some number and greater than another. So, pause the video, see if you can come up with it. All right, here comes my solution. First thing I do is I write it as 2 inequalities. 3x minus 4 is less than 2. And 3x minus 4 is greater than negative 2. All right, going to get x alone. Going to add 4 to both sides. And I will get 3x less than 6. Divide by 3, divide by 3. X is going to be less than 2. And then I'm going to add 4 to both sides. 3x is going to be greater than 2. Therefore, x is going to be greater than 2/3, right? If I divide by 3, and I divide by 3. So, I need all the numbers. Whoa, what is that? Oh dear, I just undid some important work there. X is less than 2, and x is greater than 2/3. So on a number line, I'd have the 2/3 here, right? And I'd have the 2 here. They're going to be open points. And I'm going to shade between. That's an intersection. So, I know it can't be B or D because those are unions. So I'm going to come and look and see that x is less than 2 and x is greater than 2/3. My answer must be A. Must be A. Check the answer. Ooh, I am fantastic. All right, let me erase all that gobbledygook. And there was one more I wanted to do for you. Okay, and this one says in a survey of students about favorite sports, the result is 34 who like tennis. 34 like tennis, they do. 28 who like football. 28 like football. 14 like tennis and football. 14 like tennis and football. 19 who like tennis and baseball. So 19 like tennis and BB. 17 who like football and baseball. 17 like football and baseball. 4 who like all three. 4 like tennis, football, football, and baseball. 6 who like none. 6 like none of those sports. How many students like only tennis and football? Now notice, none of the numbers I read initially said only tennis and football. They said tennis and football, but they could like baseball also. All right, so what I would do is I would make a Venn diagram. So I've got my tennis circle. I've got my football circle. And then here I have my baseball circle. Now I know the tennis number has to equal 34. I know the football number has to be 28. I don't know what the baseball number has to equal, I don't believe. All right, what can I fill in? Well, I'm told that 4 like all three. So 4 goes right there. These 4 pieces, 1, 2, 3, and 4, have to add up to be 34. Okay? Let's see here. 19 like tennis and baseball, right? Okay, tennis and baseball. Well, there's 4 that like tennis and baseball right here. So the number that like just tennis and baseball, not football, would be 19 minus 4, or 15. Do you see how I did that? This piece right here needs to equal 19 because this is tennis and baseball. Part of it includes football, but if you like tennis, baseball, and football, don't you like tennis and baseball? So this whole area has to be 19. If that part's 4, that must be 15. Now, football and baseball, there's 17. Well, that's this. So if the middle is 4, the other piece must be 13. All right. Now, tennis and football is 14, which makes this part 10. If I needed to figure out tennis only, I could subtract these numbers from 34, and that would tell me tennis only. Okay, but the question is how many students like only tennis and football? Looks like I've got my answer. 10 should be the right answer. So I'm going to go in here, I'm going to type 10, and I did nice work. All right, now you certainly can practice more of these problems. I'll have a couple problems on the board for you. That'll be it for today. Mr. Laurence signing off. Have a good night, everybody. Oh dear, how do I stop this crazy thing? Jane, stop it.